2022 A-Level Physics MCQ question number 23. The diagram shows a circuit having a battery of EMF 6 volt, a 3 ohm resistor and 6 ohm resistor connected in parallel. When the switch K is open, reading of the ideal ammeter is 1.5. What is the ammeter reading when the switch is closed? When the switch is closed. The problem is after closing the K switch, the current through the ammeter I2. I consider these two parallel resistors. The equivalent resistor can be applied for this point. The equivalent resistor is 3. We can take 3 into equivalent resistor is the shortest, the easiest way, 3 into 6. The product divided by sum 6 plus 3. The equivalent resistor is equal this R 18 divided by 9 equals 2 ohms. In this case R equals 2. But the problem is, right, okay. Now we can actually now calculate, but we have to consider the given hints. That means according to the first one, if we calculate, we can calculate I1 using this the other details. I can apply sigma E equals sigma IR, sigma E equals sigma IR. Let's take, we know I is unknown value. Therefore, I consider this circular clockwise direction, anti-clockwise direction, and sigma E 6 equal I1 into 3. I1 should be, according to this, 6 upon 3, I1 should be 2 amperes. But in this case, it is given the current through ampere is 1.5. Therefore, there is an unknown thing in this circuit. Therefore, we can't consider R equals 0. There should be a R value, internal resistance. Because if there is no internal resistance, I1 should be 2 ampere. But in this case, I1 is equal 1.5 ampere. That means there should be an internal resistance. Now we can consider with internal resistance. Definitely there is a internal resistance. Now I consider with internal resistance. And we can apply Kirchhoff's law, or V equals E equals IR plus I simple R. This is internal resistance, this is external resistor. E equals 6 I 1.5, R is 3 plus 1.5 into R. Therefore, 6 minus 4.5 equals divided by 1.5 equals R. R equals 1 ohm. R equals 1 ohm. Now we can consider the second occasion, this one. Now I can consider the second occasion, and R equals 2. R equals 1. We know R equals 1. We calculated R equals 1. 1 ohm. In this case also R equals 1 ohm. And we can apply the previous equation when E equals I capital R plus I simple r. This is we can explain as Kirchhoff's law, or we can consider as when current coming out from a battery, we can apply this equation. E equals, from this one I apply for this one, E is 6, I, the question is I, R is, the external resistance is 2 plus again I, R is 1. 6 equal 3 into I, 3I. I equals 2 amperes. Therefore, the I2 value, I2 is 2 amperes. The answer is fourth one. The answer is fourth one.